This example comes out of section 10.2, products and quotients of functions. So in this example, we're given two graphs. Rather than giving us the equations, they've given us the actual graphs themselves. Because I can't really use great graph paper here with these videos, I'll give you a table of values that goes with these graphs. So x and f of x, so the coordinates are very, very simple. We've got -3, -3, -2, -2, -1, -1, 0, 0, 1, 1, 2, 2, and 3, 3. So you might be able to put together what function that is. Now, g of x is in some ways similar, except we've got -6, -4, -2, 0, 2, 4, 6. What we're asked to come up with is a function that is the product of these two functions. So h of x equals f of x times g of x. That can be written this way, or it can be written as f dot g of x. Those both mean product of functions. And if we have a table of values especially, or even if we just have a graph, all we would really need to do is multiply the y-coordinates together. So, for example, when x equals -3, I would have -3 times -6 equals 18. So my new function that I'm calling h, which is the product of these two, literally comes from multiplying their y-coordinates together. So I'd have 8, 2, 0, 2, 8, 18. If you graph that, and I will put it on a separate set of axes only because I don't have different colors with this pen here, you find that yes, it does go through the origin, and you end up with actually a parabola that faces upward. If you connect some of these dots and plot the actual points that I've said there and plot more and more points, you'd find that you end up with a graph that looks like that. Reason being, if I look at the actual functions that I didn't give you at the start, f of x was equal to x. G of x was not much more complicated, it was 2x. So the product of those two, h of x, which is f times g of x, is equal to x times 2x, which equals 2x squared. So the graph that I've just drawn here and the points that you see up above in the table all correspond to a function of y equals 2x squared. So product of functions is very, very similar to our last lesson, which was sum and difference, except instead of adding or subtracting, a product indicates that we have to multiply.